Hi everyone, my name is Nina and I will present here my paper together with my supervisor Aleksandra Pižurica. We are from Ghent University in Belgium and this paper is about transferring the knowledge from handcrafted to unsupervised learning based local image descriptors. So local image descriptors are basically functions that map image patches to lower dimensional encoding, such that we are able to, for example, say that this region in this image is matching to this region here. And these are some examples of image processing tasks which use local image descriptors. So originally, handcrafted features were used as descriptors, like in SIFT, for example. But in recent years, with the development of deep learning, learned descriptors are more common. However, they are often based on supervised learning, which means that they require a labeled data set of pairs of patches, saying for each pair whether they're similar or not. And this is problematic if we want to specialize a descriptor for a specific domain, for example, X-ray images, because often it is not possible to find such labeled data set. And even though deep learning-based descriptors outperform handcrafted ones on benchmarks, handcrafted descriptors are still more commonly used in practice. So in this paper, we propose a framework for transferring the knowledge from handcrafted to learning-based descriptors and using only unsupervised learning. So I will now describe the general framework for knowledge transfer on a high level, which consists of 4 steps. So in the first step, we learn to mimic the handcrafted descriptor using a convolutional neural network. So basically we feed the network patches and we train it to output the encodings that the handcrafted descriptor would output. Then in the second step, we take the network from the first step and set it as an encoder part of an autoencoder, and we train only the decoder. So we're basically learning to invert the handcrafted descriptors encodings back to the patches. In the third step, then we train the whole autoencoder, so letting both encoder and decoder to be trained. And finally, in the fourth step, if we need to specialize our descriptor on a specific data set, we can retrain the autoencoder on the patches from this data set. And once we are done with the training of the autoencoder, we can discard the decoder part and we are left with the encoder, which is our descriptor. So we have applied the proposed framework on brief descriptor, which is a popular binary descriptor proposed by Calander and colleagues. And it is a simple descriptor. It basically takes a patch, blurs it, and then compares the pairs of pixel intensities at predefined locations in the patch. And for each pair, if the first pixel is larger than the second one, we output 1, otherwise 0. And this is how the encoding of the patch is computed. Now I'll describe how we used the proposed framework to make learn brief, following the general steps that I have previously described. So for the first step, we actually made a slight modification. Instead of learning to mimic the handcrafted descriptor, we were able to just implement it using the convolutional and fully connected layers. So this is the original brief. The averaging blur we were able to implement with convolutional layers, just using because averaging is convolution with an averaging kernel. And for pixel comparisons, we implemented them using a fully connected layer where we set the weights in a specific way as we described in the paper. And as for steps 2 and 3, we have implemented them as I already described in the general framework. So we have evaluated learn brief in comparison with the original brief on HPatches benchmark, which is a comprehensive benchmark for evaluating local image descriptors, consisting of 3 different tasks, each with 3 different levels of difficulty. And in all cases, learned brief did outperform original brief. Only in patch verification, the performance was the same. And on the right side, you can see some examples of patches retrieved by both descriptors. So this is a proof of concept that descriptors learned using the proposed framework can outperform their the handcrafted descriptors they are based on. Thank you very much for your attention. And you can find the code for Learn Brief on GitHub.